Hi everyone. I'm going to do a little mini lesson here. Actually, it's more of just a bunch of examples for lesson 6.4. This covers, I think, tabs 31 to 33 and tabs 37 to 44 of the algebra project. Um, and there are a couple of new things here that you may not have ever seen before. So I'm just gonna go through all the examples and invite you to follow along with me. Um, we'll see how this works. So in question one, you've not seen a question like this in an algebra context, but you've seen it in the polynomials context. And all we're doing here is combining like terms. So the first thing we need to do is to get all our b's in one place. So if we have negative 8b plus 3b, what we have combined is negative 5b, and that equals negative 10. And then we've seen this question before. I'm just going to divide this side by negative 5, going to divide this side by negative 5, cancel that out, and I get b equals 2. All right. This is just another similar example. 0 equals 5 plus 5m, because 7m minus 2m is 5m. And now I need to separate. I need my number, my constant on one side and my variable on the other. Remember, I'm always what's bothering the variable, right? So I can get rid of either the 5 or the 5m. Um, it's actually, there's a toss-up. People tend to like the variable on the left side, so that would be in favor of subtracting 5m from both sides. But then I have a negative that I'm introducing for my variable, and so I'm not going to do that. I'm going to do it the other way. You will, of course, get the same answer either way, but I'm going to subtract 5 on this side and subtract 5 on this side. So what I now have is negative 5 equals 5m. And then I'm going to divide this side by 5 because the 5 is bothering the variable. Divide this side by 5, and I get m equals negative 1. All right. These ones where I'm instructing you to divide first, it's because there are two ways to answer these questions, these next four questions. And I want you to you need to be comfortable doing it with both methods. So I'm just specifying that you're going to divide first on these two and distribute first on the other two. So let's do that. So you remember when I talk about this, when we've got brackets and the variables inside the brackets, it's kind of like an egg membrane where you know there's a variable, or maybe it's even an eggshell. You know there's a yolk in there, but you don't know exactly where it is or exactly what it looks like. You have to break the egg. You have to get rid of the shell before you can see inside the egg. So we need to get rid of those brackets, and we're going to do that this time by getting rid of this 8. So if what I had was 8x, or let's go with 2x on this side, I would divide this by 2, right? And I'd be left with x. But what I have is 8 times this blob. So I'm going to divide the whole side by 8. All right, it's really important to remember that you're always, whatever you do in algebra, you're doing to the whole side. Okay, so what I now have is 8 times this blob, and I'm dividing it by 8, and the 8's cancel, and all I'm left with is the blob. Okay, so the 8's cancel, and I'm left with 7 plus 3x. And of course I have to divide the other side by 8 as well, and that equals 13. So I have 13 equals 7 plus 3x. I can subtract 7, subtract 7. I get 6 equals 3x. Divide that by 3, divide by 3, and I have 2 equals x. All right. Just a note, you cannot do anything with the 7 or the 3x. You can't subtract 3x or divide by 7 or subtract 7 or anything until you get rid of that 8 that's outside the brackets. Okay? All right, this side a little bit more complicated because we're dividing by negative 8 this time. That's the only difference, dividing by negative 8. So what I have is p minus 6 equals negative 14. Oops, 14. So I'm going to add 6, add 6. I get p equals negative 8. Okay? These two we're going to distribute first. So if you remember the distributive property, we did this a bit, we've done this in a couple of different places. If you're struggling with the distributive property, please let me know and I can get you some specific practice just on distribution, because this is an absolutely critical skill to have going forward. Okay, so I'm not changing what there is on the right side, so I don't need to make any change to what's on the left side. I'm just changing the shape of the right side. So I'm going to have, this is going to be 4 times 8x, and I have 4 times 5. Okay? Um, you won't write that line out eventually. That just becomes, it's just while you're learning. You want to write that out so you're understanding what's going on. 4 times 8x is 32x, and 4 times 5 is 20. So I'm going to subtract 20 and subtract 20. And so I get 256 equals 32x. Divide that side by 32, divide that by 32, and I get x equals 8. So I do have a question for you here. Would this be easier to follow if I was using 2 colors? I'd really like to know. I'd really like your feedback on that. All right, now we're going to do the distribution, or the rainbow lines, or the water bombing, whatever you want to call it. Distribution is what it's technically called. So I need to multiply my -6 times the 7 and the -2x. So I think the clearest way to write this is that I have -6 times 7 and I have -6 times -2x, and that equals -126. So this becomes -42 plus 12x equals -126. I'm going to add 42 to both sides. 12x equals -84. Divide that by 12, divide that by 12. I get x equals -7. Okay, conceptually, that's all that's new. We'll just do some more examples, some more practice using decimals, and then some with fractions. All right. So I'm going to collect my like terms. I'm going to get my n's together. So on the left side I have 1.32, and on the right side I have 1.4n minus 1.2n gives me 0.2n. And then I'm going to divide that by 0.2, divide that by 0.2, and I get 6.6, negative 6.6 equals n. And over here, so this time I have a couple of things I can do at the same time. I can see that I'm going to combine my like terms here, but I also need to move this constant to the other side, or get rid of it on this side. So I'm going to add the 5.6 here, and I'm going to add the 5.6 here. Those cancel out. And then I have -2.7n plus 0.9n is -1.8n. And that equals -1.8. And then I'll divide that by -1.8, divide that by -1.8, and I get n equals 1. Question 9. So here's an example where I could distribute first or I could divide first, because either one will work. Generally speaking, if I were to divide this side by 5, I would have to divide this side by 5, which introduces a decimal. So I'm probably not going to do that. In this case, I'm probably going to distribute it. All right. Again, you get the same answer either way. I just think this is easier. If this was -120, I would definitely divide both sides, because then this would be an integer. Okay. So I have 5 times 1 is 5, and I have 5 times 4.5, which is 22.5x equals -121. And then I need to subtract 5 and subtract 5. So I have 22.5x equals -126. If I divide both sides by 22.5, I end up with x equals negative 5.6. Question 10. So this time, there's no value in me getting rid of this negative 4x because there's an x here. And I want to keep my x's on the same side because I need to collect them. So this time I really need to distribute first. So I'm going to do the distribution first. So I have negative 4x because that doesn't change. And then I have minus 3 times 3.1x. And I have negative 3 times negative 5.3. And that equals 119.64. Eventually, I wouldn't write this plus. I would just put minus 3 times negative 5.3, and then eventually I would skip this line entirely. But while you're learning, write out all the work because it helps you keep track of what's going on. It helps you understand what's going on, and it helps you remember what you're doing. Okay? All right, and then this is plus 15.9. And that equals 119.64. So I can do two things in one step now. I can subtract my 15.9 from both sides. And I can also combine these like terms. So negative 4 minus 9.3 is negative 13.3x. And that equals 103.74. And then I'm going to divide this by 13.3 and divide this by negative 13.3, and I get x equals negative 7.8. Okay. Would I check my answer on this question? Abso-freaking-lutely. Okay. So that's actually something that next time I teach Math 9, I'm actually going to have students spend more time doing is just calculator work, believe it or not. Putting the number in for x and trying it on your calculator and make sure you get the right answer. So I invite you to check your answer on all of these questions, always, always, of course. All right. Fractions. Okay. Remember, a fraction is just a number. It's just an ugly number. The process is always exactly the same. Okay. So on the left side, I have two terms that have k in it, and I have the negative 1/3. So I'm going to do two things at once. I'm going to add 1/3 to this side, and I'm going to add 1/3 to this side. So that cancels out. And then looking ahead, I can see that I'm going to have a denominator of 3. So I'm going to write my 1k, I'm just going to write it as 3 over 3k so that I can add it to my other fraction in the next step down. And then I have 3 times 3 is 9 plus 1, so this is 10 over 3k. And on the right side, this is going to be 61 over 12. And I'm adding a third to it, but I'm going to write my third with a denominator of 12, so that's going to be 4 over 12. Okay, so you can see I'm actually combining several. I could have written this out as like 3 or 4 different separate steps, but that seems like a waste of time to me, and I don't need that particular stepping stool. If you need that stepping stool, then please do it. Please do it the way that works for you. All right. So now I'm going to combine these like terms. So I've got 3 over 3 and 10 over 3. That's 13 over 3k. And that equals 65 over 12. Okay. And instead of dividing it by 13 over 3, I'm going to do what's essentially the same thing, which is I'm going to multiply both sides by 3 over 13. I'm going to multiply it by the inverse. Okay, so these 3's cancel, these 13's cancel, and all I'm left with on the left side is the k. And on the right, I can go, well, 3 goes into 12, so if 3 divided by 3 is 1, 12 divided by 3 is 4, and I'm going to pull out my calculator, and I think 13 goes into 65. I'm going to check that because that would be a nice thing for it to have work, right? Turns out that 65 divided by 13 is 5. 13 divided by 13 is 1. And my result then is that k equals 5 over 4. Okay? over 12. Very similar, actually. So I'm going to add the 1/2 to cancel that out, and I'm going to add the 1/2 on this side. And then I've got negative 29 over 12 plus 1/2, but I'm going to write that as 6 over 12. And I'm going to write this v as 2 over 2v minus 3 over 2v. On the left side, negative 29 twelfths plus 6 twelfths is negative 23 twelfths. And if I have 2/2 of a v and I take away 3/2 of a v, I have negative 1/2 of a v. And I'm going to multiply this side. Whoops, change colors there. Multiply this side by negative 2 over 1. And I'm going to multiply this side by negative 2 over 1. So on the right side, my 2's and my 1's cancel, and my negatives cancel. And on the left side, my negatives cancel, so I'm just going to change them both to pluses. And the 2 and the 12 cross-reduce, so this becomes 1 and this is 6. And my answer is 23 over 6 equals v. Two more questions. I'm going to change this to an improper fraction. So this becomes 451 over 5. And again, I could have divided both sides by 4, but when there's a fraction, I really don't want to do that. So I'm not going to do that. So this, now I have negative 4 times, oops, this pen has just started doing this really annoying thing where it bleeds. Okay, minus 4 times. I'm going to rewrite this negative 3 and 3/5 as an improper fraction. So 3 times 5 is 15 plus 3. So this is minus 18 over 5a. And I have negative 4 times negative 5. So this is 451 over 5 equals 4 times 18 is 72 over 5a, and it's going to be positive because it's negative 4 times negative 18, and then plus 20. There are a bunch of ways that you can do it from here. I'm going to subtract 20 from both sides. Subtract 20. So this side becomes 451 over 5 minus 100 over 5, which is 72 over 5 times a. So I have 351 over 5 equals 72 over 5 times a. So which equals 72a over 5, right? It's just different ways of writing it. So one thing that we can do here, I'm going to just scribble out this middle thing here. If I multiply both sides by 5, if I do the same thing to both sides, right? If I multiply this side by 5 and I multiply this side by 5, the 5's cancel out. So anytime I have two fractions with the same denominator on different sides of the equal sign, the denominator doesn't matter because 351 has to equal 72a. 72a. Okay. And then I'm going to divide this by 72, divide that by 72, and I get a equals, it reduces to 39 over 8. And a reminder that if your question is written in fractions, your answer must also be written in fractions. Okay, last example. This is already an improper fraction, so I don't need to do anything with it. So I've got 5 over 4 equals, yeah, I need to keep all of these together because there's x's inside and outside the brackets. So 2 times 4 is 8 plus 1, this is 9 over 4x, minus 7 times 31 over 7x, minus 7 times 5 over 7. And then look at this, the 7s are going to cancel out, right? Because that's multiplication. I can cross-reduce both of those. So that's handy. And I get 555 over 4 equals, I'm going to rewrite this, 9 over 4x minus 31x minus 5. So I will add 5 to both sides. Okay, so I've got 555 over 4 plus, I need to write my 5 with a 4 in the denominator, so that's 20. And that's 9 over 4x minus, and I need to write my 31x as something with 4 in the denominator, so 4 times 31 is 124. Back on the left side, I have 575 divided by 4 equals 9x minus 24x. This is going to be minus 115x over 4. And so the 4's just go away because, I mean, I say they go away, but really what I do is I multiply this side by 4 and I multiply this side by 4 and the 4's cancel. So I get 575 equals negative 115x. Divide that by negative 115, divide that by negative 115, and I get x equals negative 5. All right, I hope that helps. That felt really fast. I hope you are slowing down to look at this. If you need any more help, send me an email. Have a good day. Bye.